Good morning and welcome to this lecture. I think we are in the sixth lecture and we are about to finish X-rays, right? Do we recollect what we studied in the... Okay, you can't speak. What we studied in the last class in X-rays? We were dealing with the type of X-rays. Yes or no? We were dealing with type of X-rays and I think we had seen continuous X-rays, continuous X-ray spectrum, where we saw that this continuous X-ray spectrum does not depend on the target metal, whatever be the target metal. We will have a continuous X-ray spectrum and we had a minimum wavelength below which there will not be any X-rays. Above that minimum or threshold wavelength, we will get X-rays of all possible wavelengths. We understand that? We remember that? That wavelength is known as what? That wavelength is known as what? That wavelength is known as the threshold wavelength. Yes or no? I hope we remember this. I'll just show you the diagram once again of the last class just to have a recollection of what we had done in the last class. So we had seen for continuous X-rays, and I think right now it is on your screens. On continuous X-rays, we have a minimum wavelength that is known as the threshold wavelength. Yes or no? You got the mic right? Yes, okay. And we had seen the formula for this. Again, 12,400 comes. Same 12,400 that we saw in photoelectric effect. And we have a maximum frequency. And we had seen this diagram, this graph, a very important graph. More voltage, the wavelength is less. Less the wavelength, more is the energy. So you must understand that if you want to produce hard X-rays, which are X-rays which have more energy means more frequency means less wavelength. You have to increase the potential difference between the cathode and the anode. I hope you understand this. Well, this is one type of X-rays. We have seen X-rays can be divided into different types. One is soft and hard X-ray. Soft is having more wavelength, less frequency, less energy. Hard is having more frequency, less wavelength, and more energy. They can penetrate more. Then we had seen one type of X-ray is known as continuous X-ray, which does not depend on the type of the target metal. It only depends on how much potential difference we have applied. More the potential difference, less is the wavelength, and more is the frequency, and more is the energy. But we must also understand that there would be, I think we have seen this point, golden key point. Let me just again show you, just to make a point. And the point is pretty simple, and the point just says that continuous X-rays, which are also known as white X-rays, I think we have seen that point. Minimum wavelength of the spectrum only depends on the applied potential, and it does not depend on the atomic number. That means it does not depend on the type of the target metal that we are using. You use any metal, you will have this continuous X-rays coming. Now that takes us to a point where we should understand, or where a question should come to our minds. Sir, I mean, the target metal, there must be some X-ray, there must be something for that X-ray that depends on that target metal. Otherwise, we can put any metal and we will get X-rays. There must be something, some X-ray, which depends on what target metal we are using. We are using iron, we are using copper, or anything that we find in the universe. There must be some X-ray which depends on those target metal. And those X-rays are known as? Any idea what those X-rays are known as? These X-rays depend on the type of the target that we are using, and hence the name characteristic spectrum of X-ray. Characteristic refers to the target metal, that this depends on the characteristic of the target metal. For different metals, we will have different types of X-rays coming here. Do we understand this? So there is one type of X-ray which does not depend on the target. There is another type of X-ray which depends on the target metal. Now we had seen how these previous X-rays were produced. There was a photon, there was an electron which was trying to hit that target metal, and it was getting deaccelerated. When it was getting deaccelerated, it was losing energy, and that energy was coming in the form of that energy which is lost. A part of that energy, 1 to 2% of that energy, was coming in the form of X-rays. The rest was lost in the form of heat. Do we understand this? Do we remember this? Can I have some raised hands?
Yes, sir. Yes, sir.
Okay, that was continuous X-rays. That is how continuous X-rays are produced. Now let us try to understand how characteristic X-rays are produced. And to understand this, what I'm going to do is I'm going to show you this diagram on a bigger scale, and then you will draw this diagram and try to make sense of what is happening here and how these characteristic X-rays are produced. I think my diagram got I should make it larger so that you can see it on your screens. I hope it is now more visible to you, the entire diagram. Yes or no?
Yes, sir.
Yes, sir. No, sir. Then, sir, tell me, sir, what is happening here, sir? The diagram is a slightly different one compared to the diagram that we had previously shown for continuous X-rays. Can you spot the difference? Can you spot the difference? What is happening? What was happening there and what is happening here? Anyone can spot the difference? Anyone can spot the difference? Tell me. This is the striking electron. Yes or no?
Yes, sir.
After striking, it is going out. Yes or no? The initial velocity was V1, the final velocity is V2. V2 is less than V1. The loss in energy is coming in the form 1 to 2%. Remember the percentage, 1 to 2% only. 98, 99% is going to get converted into heat. And that is why this target metal is going to get very hot and it has to be having a high melting point. Okay. What is happening here? What is the difference here? Again, the electron is striking and it is going out. But is it striking differently now?
Yes, sir.
What is the difference? What is the difference? As you can see here, this is the K shell, this is the L shell, this is the M shell. Yes or no?
Yes, sir.
All these shells have different electrons revolving in that shell. Yes or no?
Yes, sir.
Now, in this characteristic X-rays, what is going to happen is this striking electron in red is going to displace or knock out one electron. One striking electron may knock out another electron which is revolving in the shell. Do we understand this?
Yes, sir.
If it knocks out any electron from the K shell, the electron will get energy. It will jump to the higher shell. We understand this?
Yes, sir.
From chemistry, if I give sufficient energy to electron in the lower shell, they can move on to the higher shell. When they lose energy from the higher shell, they can come down to the lower shell. We understand this?
Yes, sir.
That's it. That's it. So, what is going to happen now? If I knock it out, or I should say the reverse, from higher shell, if I knock an electron out, higher shell has lower energy, lower shell has higher energy. Do we remember this energy wala concept? Energy of a shell inversely proportional to n square or something like that. Do you remember that?
Yes, sir.
So if I knock an electron from a higher shell It will come down to a lower shell.
Yes, sir.
Then what will happen? It will emit certain energy. Yes or no?
Yes, sir.
That energy will be going in the form of X-ray.
X-ray.
So in this characteristic X-rays, what is going to happen are electrons are going to strike the shell wala electrons, and those electrons are going to get knocked away. When they get knocked away, the difference in energy between the two shells, that much amount of energy will be going out in the form of X-rays.
X-rays.
And therefore we have different type of characteristic X-rays. One is known as the K series X-rays. Then the other one will be known as
L series.
L series, and the other one will be known as,
M series.
depending on from which shell electrons have been knocked off or electrons have been coming back. Do we understand this?
Yes, sir.
Can you draw this diagram now?
So we got sheets.
You got sheets? That's
Yes, sir.
good, sheets, sir, but still you have to draw it. You have got
Okay,
sheet, that does not mean that you will not draw it. You will still draw it.
Okay, sir.
See, try to understand better. This is not biology that you can remember things. If you draw it with your own hands, you will never forget it, because there will be a question coming based on this. So just draw it. You may just write everything in short. If you have got sheet, just write everything in short. Just write everything in short so that you understand point wise what you have to remember, and the explanation you can write it from the sheet that you have. You can draw it from the sheet that you have, and the explanation which I am going to make you understand now in very short. What we are going to do, ting ting ting, I'll just change the color of the pen. Okay, so this characteristic X-rays will depend on what? It depends on how many electrons I have, how many shells I have, and how many electrons and how many shells depends on what? It depends on the
Target metal.
it depends on the target, and hence characteristic spectra depend on the target. So when the target is struck by electrons, two types of radiations are emitted. One of these is a continuous. We have already seen that, whose wavelength only depends on the potential, while the other consists of spectral lines whose wavelength depend on the nature of the target. Do we understand this?
Yes, sir.
This radiation is known as characteristic X-rays. Do we understand this?
Yes, sir.
When highly accelerated electrons strike with the atom of the target, then it knocks out the electron of orbit. Due to this, a vacancy is created. Do we understand this?
Yes, sir.
To fill this vacancy, electrons jump from higher energy level, and electromagnetic spectrums or radiations are emitted. This is known as characteristic X-ray. Do we understand this?
Yes, sir.
So this is the phenomena. Electrons get knocked out. There is a vacancy that is created. The vacancy has to be filled. When the vacancy is filled, electron jump. When electron jump, voila, we have X-rays being emitted. Do we understand this?
Yes, sir.
Have you noted this down?
1 minute, sir.
Okay, sir. Characteristic X-rays depend on the target. Have we noted it down in short?
Done, sir.
Done, sir. Then, sir, this, sir, next thing, sir. We must understand this, sir, that it depends on the nature of the target. Yes or no?
Yes, sir.
If N1 is 1, first shell, something jumping from higher shell to first shell, we know that this is known as alignment series. Yes or no?
Yes, sir.
If something jumps from higher shell to second shell, we call it a Balmer series. Yes or no?
Yes, sir.
Third shell, Fasten and Bracket and Fund and all those series. We remember this.
Yes, sir.
Now, this is what is going to happen when we have vacancies in the lower shell. And what happens if I knock out an electron from the K shell? Then what will happen? If I knock out an electron from the K shell, then what will happen, bacha?
J series.
K series, there will be a vacancy in the K shell. Electrons will be jumping. Electrons will be jumping from higher shells. Yes or no?
Yes, sir.
The first line is from number 2 to number 1. That is known as alpha. We understand alpha. Alpha, alpha, alpha. That is known as K alpha series. If it jumps from n is equal to 3 to 1, it is known as beta series. Do we understand this, bacha?
Yes, sir.
If it jumps from the 4th, it will be known as gamma. If it jumps from the 5th, it will be known as delta. Do we understand this?
Yes, sir.
This is all about K series. Then for L series, the orbit is 2. If it jumps from 3 to 2, it becomes alpha. Do we understand this?
Yes, sir.
Then beta, then gamma. Then we have M series, we have N series, and so on. This is known as characteristic spectrum of X-rays. We understand this?
Yes, sir.
Have you drawn this diagram, bacha? Simple diagram. Simple diagram. Simple diagram. And the simple diagram has the first line in the series, that is from the next higher orbit. If it makes a jump, it will be alpha. From the second next higher orbit, if it makes a jump, it is known as beta. From the third next, it is known as gamma, and so on. Do we understand this, everyone?
Yes, sir.
Can I have some raise hand that we understand this? Girls, do we understand this? Okay. That is all about alpha, beta, gamma, K series, L series, M series, N series, and so on. This is all that you need to know and remember. About the series. Will you remember this?
Yes, sir.
Okay. Now, the thing is, if it makes a jump, photon or X-ray will be emitted. What is the wavelength of that photon or X-ray? Now, that wavelength does not depend on the applied potential, because it only depends on from where to where this jump has been made. Yes or no?
Yes, sir.
Yes, sir. No, sir. Then, sir. See, sir. What is happening, sir? We have this table, sir, which has been very nicely put. So for K alpha series, the jump will be made from L to K. Yes or no?
Yes, sir.
Lambda will be known as lambda of K alpha. Frequency will be known as F of K alpha. The energy will be H into F. We understand this? Yes, sir. No, sir. Say, sir.
Yes, sir.
Then, sir, it will come because of energy difference between K shell and L shell, sir. That will be equal to H alpha K series, sir. K alpha series, sir. From here, you will get the formula for alpha for K alpha series. Yes or no? Lambda for K alpha series. Yes or no?
Yes, sir.
Again, sir, we have H multiplied by C, sir. So H multiplied by C, sir, becomes what, sir? 12,400, sir. Yes or no, sir?
Yes, sir.
We divide this by K, energy of K shell minus energy of L shell. we will get alpha of, we will get lambda or wavelength of K alpha series, and the answer, the energy which should be in electron volts, then the answer will be coming in Armstrong unit. Do we understand this, sir?
Yes, sir.
This is the formula that you remember for lambda of K alpha series EK minus EL. Do we understand this?
Yes, sir.
Similarly, the formula for lambda of K beta series, everything remains same, HC divided by EK minus EM. Remember, HC can be written as 12,400. Then energy must be in electron volts. You will get the answer in Armstrong units. Are you noting down this formula? Yes or no?
Yes, sir.
Yes, sir. Then, sir, this is the formula that we get for lambda of K beta 12,400 divided by EK minus EM. Similarly, we have L series ka alpha. What changes is EL minus EM. Do we understand this?
Yes, sir.
I'll give you a minute to note everything down. It's already there in your sheet, so you can very easily see it. And now we have the entire picture of what would the spectrum of X-ray look like. Have we noted down this formula, bacha? Done, sir?
Done, sir. Oh,
Then, sir, this diagram, sir, which is the most important diagram, sir, and many questions will come on this diagram. What are the things that you must note about this diagram? I will give you a minute and then I'll ask you what are the things that you understand from this diagram. I will make it big. I like big things so that you can see it bigger. So I'll make it bigger. Oops, 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 oops. How do I make it bigger? Yes, sir. Sir. It becomes big, sir. Then, sir, tell me, sir, what do you understand from this diagram, sir? This is the entire spectrum for one from some target metal. Can you understand and tell me the important points? Note them and keep them in your head always. This is the entire spectrum, the entire X-ray spectrum, which we can expect, which we are going to find when we strike any target metal with fast moving electrons. What are the important points that you see here? Tell me. Hmm? You don't understand anything looking at the diagram?
yes, sir.
What, sir? That is what you have to tell me, sir. Because that question will come in the exam, sir. Then, sir, I will not be there, sir. To tell you, sir, I answer, sir. Hai sir? Are you going to say or shall I babble? Any idea what you understand from this diagram, or you just drawn this diagram and said, okay, now God will help us. Because we have drawn the diagram, everything will come into our head straight away. Someone is going to implant it
K
using
alpha
a
has more
USB drive directly into our brain. Yes?
K alpha has more X-rays or intensity.
Straight away jumped for K alpha because K alpha is the highest. Okay, not bad. Not bad to start. Why is K alpha highest? Energy of alpha. Why is it highest? K alpha. Okay. What you got to understand here, is first, think about this lambda minimum. On what factor does this lambda minimum depend on? On what all factor does this lambda minimum depend on? Tell me. Again, you are going back in the past. You keep looking back in the past, you will never see your future. You only see your past self. Your past self is always stupid. Yes, tell me. On what all factor does lambda minimum depend on?
Potential difference, target.
It depends on the potential difference V. If I increase the value of V, the lambda minimum will go? Will go?
Increase.
Up or down?
Up.
Shabash, this is what you have understood. You have always understood it wrongly. So what is the first thought that comes to your mind looking at a question? You always give the other reply. Do you understand this?
Yes, sir.
Yes, sir. And I'll not tell you how it comes, sir, because I have told it 15 times, sir. Okay, so this lambda minimum only depends on the potential difference. And therefore, we have this continuous spectrum. It does not depend on the type of the metal. But then we have these spikes in between. And what are these spikes? All of a sudden, we get a spike. These spikes are coming because of the characteristic X-rays, because electrons are also going to be knocked off from their inner shells. And the most number of electrons are knocked off. From your K shell. Do we understand this? Do you see that?
Yes,
And when it gets knocked off from the first shell, the third shell will not jump to the first shell. The first thing that will happen will be the second shell wala electron will jump onto the first shell. Yes or no?
yes, sir.
And therefore, we have highest intensity or highest number of X-rays of K alpha series. Do we understand this?
Yes, sir.
But K alpha series, now look at the wavelength of K alpha series. This is the wavelength of K alpha series. This is the wavelength of K beta series. And this is the wavelength of K gamma series. Now, wavelength of K alpha, K gamma, or K beta depends on the difference in the energy levels. Yes or no?
Yes, sir.
K alpha depends on the difference in energy level of K and L. K beta depends on K and M. K gamma depends on K and N. Yes or no?
Yes, sir.
Which one has the lowest difference? K shell and L shell, K shell and M shell, K shell and N shell. Which will have the lowest difference of energy? The L shell and the K shell and the L shell will have the lowest difference in energy, and therefore we have the highest wavelength. Alpha series, K alpha series ka wavelength will always be higher than K beta, K gamma. Do we understand this?
Yes, sir.
So the wavelength will always be in this ratio or this series. Alpha series will always have the maximum because it is the difference between two consecutive shell. The difference between two consecutive shell is always the minimum. We understand this?
Yes, sir.
Then we will have K beta series coming, and then we have the K gamma series coming. Do we understand this?
Yes, sir.
Do we see the same trend here? Alpha series has this wavelength, beta series has this wavelength, and gamma series has this wavelength. Do we see the same trend here?
Yes, sir.
So if a question comes, which is the correct spectrum, they might replace this alpha with beta and beta with gamma and gamma with theta and for falana dhimaka. So now you understand how to find out the correct answer.
Yes, sir.
K alpha series should have the maximum wavelength. Beta will be next, gamma, delta, theta, whatever will be coming afterwards. Which will have the most energy?
K alpha.
Do we understand this?
Yes, sir.
So that is how you find out the correct answer from the given options. I hope you have understood this and you have noted this down. Yes or no?
Yes, sir.
Pakka, sir?
Yes, sir.
Shall I move ahead, sir?
Yes, sir.
Okay, then we come to the what? Then we come to your periodic table, and I hope you know a lot of things more about the periodic table than me because I am not a chemistry guy. Have you heard about this name? No, who discovered this periodic table? Who was the first one to make this periodic table, and what came afterwards? Do we remember this?
Ghostly.
Mosley comes here. Mosley, why did Mosley do it? And this is how Mosley did it. How did Mosley do it? Physics, chemistry only gives you faltu bhandas. That this is how the electrons were or the atoms were arranged, metals were arranged. Physics tells you how it was arranged. He got it from the characteristic spectrum of a number of elements. समझ में आया? And he was a big mathematician, and he discovered that the square root of the frequency, what? He found out the frequency, found the square root of that frequency. The square root of frequency of the K line means the key series, is closely proportional, almost directly proportional to the atomic number. Do we understand this?
Yes, sir.
And this gentleman gave us the gentleman law, the Mosley's law. He said that frequency root over under f is proportional to z, which is the atomic number, minus b. B is known as the screening constant. Just remember it as a screening constant for alpha series. For K series, the value of B is 1. For L series, the value of B is 7.4. Don't worry, this B ka number, B ka value will be given to you. What you got to understand? Is this frequency is proportional to Z minus B square. This is known as Mosley's law. If you remove this proportionality sign, A will come, which A is a proportionality constant. Do we understand this?
Yes, sir.
That is how we started to arrange things in that way. Got it?
Yes, sir.
That is why he said that. I think he said that atomic mass is not the correct way of arranging atoms. Atomic number is the one, right? He was the one in terms of atomic number. Yes or no?
Yes, sir.
Yes, sir. So, sir. Now, sir. Yes, sir. Now, sir. Now, sir. No, sir. That, sir. It was done by the characteristic X-ray spectrum, sir. So, sir. Please, sir. Note it down, sir. Up till where, sir? Up till here, sir. Equation number 1, sir. I'll give you a minute, sir. You got this, sir?
Done, sir.
Then, sir, we are now going to compare what you have studied, sir, which is known as the Bohr model. Have you studied this Bohr model? Yes or no?
Yes, sir.
From this Bohr model, you have seen that when it makes a jump from higher to lower shell, you have this equation RC, R standing for the Rydberg constant, C standing for the speed of light, and Z standing for the atomic number. Yes or no? 1 by n2 square minus 1 by n1 square. You will remember this Bohr's model?
Yes, sir.
Now you have the Mosley's model. If you compare both these models, sir, you will get to know that the value of this A will be coming something like this. Yes or no?
Yes, sir.
The only thing that they have taken is here they have Z square, which Bohr said it should proportional to Z square. Mosley is saying that they are, gentlemen, this is not proportional to Z square. It is actually proportional to Z minus B ka whole square. Do we understand this? The difference?
Yes, sir.
And therefore, he corrected the Bohr's model. This proportionality constant A, according to the Bohr's model, only dependent on Z. Bohr said, is only dependent on Z. Trust me. But then mostly found out that it is not only dependent on Z, but it is also dependent on the transition from where to where the transition is happening. Do we understand this?
Yes, sir.
Yes, sir. Then, sir, he gave a correction, sir, and this is the corrected model, sir. I hope you know this model, you understand this, and then you can write this. So this is a revision of your entire thing that you have done in chemistry in the Bohr's model. This is the Bohr model. This is the Bohr model for single electron species. This is how the Bohr model goes. I hope you understand change the difference in energy, the frequency, and the inverse of the wavelength. Do you understand? Do you remember the equation on the left hand side?
Yes, sir.
Yes, sir. You remember this equation? Yes, sir.
Yes, sir.
Then you see 13.6 electron volts wala funda hai, and here you see 13.6, but you see Z minus B square because now it depends on the screening constant. It depends on from where to where the jump has been made. Do we understand this?
Yes, sir.
This is the time that you note this thing down. I'll give you a minute to win it.
Done, sir.
We have done this.
Yes, sir.
Then, sir, we can have a shortcut, and this is the shortcut that you will have to understand and remember. If the target is same, wo R C Z square wala terms is same, so lambda is inversely proportional to 1 by n2 n1 square minus 1 by minus 1 by n2 square. Do we understand this?
Yes, sir.
When transition is same, so I am making the same jump from same n to same n, same n1 to same n2. Lambda is proportional to 1 by z minus b whole square. Do you understand this? These
Yes,
are the
sir.
two important, very important formulae that you must keep in your head whenever you solve the question. Do we understand this? Please note it down. Important points. Done this?
Done, sir.
Then, sir, this small star question, sir. Find out the wavelength of K alpha for X-rays. The values are given. It is alpha series, so the higher orbit is n is equal to 2 and the lower orbit is n is equal to 1. We understand this?
Yes, sir.
And the value of B is 1. Do we understand this?
Yes, sir.
Can you now tell me the answer? What will be the wavelength of K alpha series? We already know the formula. I've already given you the formula. Yes or no, bacha?
Yes, sir.
Then, sir, please, sir, use, sir, the formula, sir. And if you still don't remember it, I'll just help you once. I should not be helping you, but I look at your bola bola faces and I feel that I should help you. So I would help you with the formula also, and the formula comes right now on your screen in big. This is the formula. Apply it, get the answer, stay happy. Got this? I don't have much time, so what we'll do? I'll just solve the question. So what you got to do? In place of R, I put R. In place of B, I put 1. And there's some misprinting. It is 1 by 1 square minus 1 by 2 square. Do we understand this?
Yes, sir.
Yes, sir. Then, sir, what do I do, sir, is I put the values, sir. The Lidberg constant and everyone. And then these are some important things that you must remember as shortcuts, because you are very likely going to get question on the same thing. So these are the shortcuts that you remember. So 1 by lambda of K alpha will become 3 by 4, 1 by 1 square. 1 by 1 minus 1 by 4 becomes 3 by 4. We understand this, yes or no? So the formula starts to look like this. The Lidberg constant is 1.097 into 10 to the power 7. 1 by R. It's a very important thing that you remember. 1 by R is 912 Armstrong units. I put the values here. This is the shortcut formula by putting all the values that I get for alpha series, K alpha series, lambda for K alpha series. Instead of 12,400, I have 1216. The more such numbers you can remember, the easier for you to solve a question in the examination hall. Do we understand this?
Yes, sir.
This is the wavelength for K alpha, this is the frequency for K alpha, and this is the energy for K alpha. Ka shortcuts by putting in all the above values. The more you can remember, the more you will be able to score quickly in the examination hall, because in the examination hall, you will not get sufficient time. Do we understand this?
Yes, sir.
Have you noted it down, sir? Now the question is, how do you remember, sir? So I have told you my way of remembering it. I'll make a big chart of all these values, put in front of me in modern physics. I'll make a big chart. I'll write all these things on that big chart, and every second of my life, for the rest of my life, till the NEET exam, I will be watching that chart. And slowly, slowly, those things will start entering my head. Do we understand this?
Yes, sir.
Have you noted it down, sir? The shortcuts. Shortcuts.
Yes, sir.
The more the shortcuts you remember, I have told you my way of remembering it. I can't help you more. You are not a laptop that I can have everything on this USB drive and I put it in your head and everything goes inside. You are much, much sharper than a laptop. So you have to remember it with your own processing path. That takes us to this graph. Again, all these graphs are so important that the same graph will come to you in examination hall. Then please don't say, sir, what to do, sir. This is a graph between the root of frequency and Z atomic number. Do you understand this?
Yes, sir.
And it is directly proportional. Do we understand this? Root of V is directly proportional to Z minus B, and therefore the graphs are straight line. The alpha series will have less. The beta series will have more because the difference is more. Do we understand this?
Yes, sir.
That, sir, would be good enough for you to do or solve any question on X-rays, sir. And that is my writing to you. That is my confirmation to you in writing that if you can do this thing, there cannot be even a single question that you will not be able to do. If you cannot do any question, you can blame it on me. But I'm sure with this much of knowledge, this much of studies, you should be able to crack it in the examination hall. Now there are two small topics that may not come. So I'll just go through this. Absorption of X-rays. I have not seen this ever coming in the examination hall, and I don't know whether it will ever come, but this is how the absorption comes. If a question comes, you just remember the formula. How it comes is out of the purview of this course. How much X-rays are absorbed, that is it. These are the X-rays which are incoming. Do we see this?
Yes, sir.
These are the X-rays which are outgoing. Do we see this?
Yes, sir.
And this is how they are related. The outgoing X-ray, I, intensity of the outgoing X-rays is equal to I naught into e raised to the power minus mu x, where I naught is the intensity of the incident ray, I is the intensity of the emergent ray, and mu is the absorption coefficient. How much X-rays can absorb, my dear friends? Do we understand this?
Yes, sir.
If I write it in a different form, this is how it looks like. How do you find the thickness of this sheet? X will be equal to 2.303. It comes because of log to the base E and log to the base 10. 2.303 log to the base 10. I naught by I. Don't tell me how. Don't ask me how this comes. This is how it comes. You just remember this formula, this diagram, and this formula. I'll give you a minute to note it down. There's nothing to understand here. You just need to understand the terms. If this question comes, just babble it out. They may not ask you to find out the value. They may just ask you the formula. Got it?
Yes, sir.
Please note it down, sir. Noted it down, beta?
Yes, sir.
Then, sir, this, sir, the intensity increases or decreases exponentially. Maximum absorption is lead, and that is why lead is used. You must have seen in X-ray lab, lead is used. The lining of the wall are covered by leads. Do we know this? Yes or no?
Yes, sir.
Some of you might be having their own X-ray labs. You'll be covering it with lead, but again, the problem with lead is it's radioactive as well, and therefore you have to be very careful. I have seen some very good doctors who had their own labs. They had some diseases which are a byproduct of working in an X-ray lab. Do we understand this?
Yes, sir.
Be careful, sir. The minimum absorption is air, sir. So never come in the way of X-ray, sir. When you are in air, sir, everything will go through your half thickness. This half thickness is something like half-life. Do you know half-life? That will coming in the next class. Half-life. Radiative decay, half-life. Yes or no?
Yes, sir.
So half thickness is the distance traveled by X-ray when the intensity becomes half, and the formula is 0.9693 by mu. Don't ask me how it comes. This is the value it comes. Please note it down. Have you noted it down, bacha?
Done, sir.
Again, one of the topics that has one question has come way back, diffraction of X-rays. So what is this diffraction of X-ray? We will not go much into detail of this. You just need to remember this formula for this diffraction. 2d sine theta is n lambda. You just remember, you just draw this diagram. There is nothing that you are going to understand here. You just have to remember this formula. This will never come. Only has come once or twice in the entire history of the paper. Since it has come once or twice, that's why we are doing it. 2d sine theta is equal to n lambda with that diagram. D is the spacing of the crystal plane. As you can see here, D, yes or no?
Yes, sir.
Theta is known as the Bragg angle or the glancing angle. We will understand this glancing angle when you do diffraction or something like that. Phi is the diffracting angle. This is the diffracting angle. This is the glancing angle. Do we see this?
Yes, sir.
For maximum wavelength, theta, sine theta should be equal to 1 or theta should be 90 degrees. Do we understand this?
Yes, sir.
Lambda max is 2D. This is the only formula that you must remember. That's it. Again, there is nothing that you can understand here. There is nothing that you can understand here. You just have to remember this. There are many questions in your NEET exam that just comes on your knowing the fact. Do we understand this?
Yes, sir.
Have you noted it down, sir? And these are some topics which are never discussed in the class, diffraction of X-rays. So if there's a question comes, probably you will be among the very few who would be able to answer this. Have you noted it down?
Yes, sir.
Then, sir, this, sir, again, characteristic of X-rays, many questions have come straight away from this characteristic. So you must remember each and every characteristics. Biology or becoming a doctor is more about remembering things. Do we understand this? Yes or no?
Yes, sir.
You have to remember a lot of things. When you are writing a prescription for a patient, you cannot look at the book. Okay, he's having headache, so what tablet I should go? I have forgot the name. I'll just look in there. You cannot do that. Will it look good? If you look at you should Google the name of that tablet before prescribing it. Will that look good? Yes, sir or no, sir?
Yes, sir.
It will not look good. So you have to remember it. This is how you develop your remembering skill, because that is going to help you out. Cat is X-ray, they always travel with the speed of light. Yes or no?
Yes, sir.
It's an electromagnetic radiation. It shows both particle and wave nature. Yes or no? Photon के type में आता है. It has dual nature. In reflection, diffraction, it shows wave nature, but in photoelectric effect, it shows particle nature. We have already covered this. Yes or no?
Yes, sir.
There are many times a question being asked. Can X-ray be deflected by electromagnetic field? No, it has got no charge. It cannot be deflected by electromagnetic field. Yes or no?
Yes, sir.
It is invisible. You cannot see it, not in the visible range. They do affect the photographic plate. When they hit a surface, they will exert pressure. Yes or no? We all know this. Characteristic X-rays cannot be obtained from hydrogen because the difference of energy in hydrogen level is very small. One important topic on which a straight question can come. Please note them down. Remember them. If you don't want to note them down, remember them always, because you will see straight away questions coming from this straight away topic. Do we understand this?
Yes, sir.
Will you remember this? This is all about your remembering.
Okay, sir.
Okay, sir. Shall I move on to some questions, sir? One or two questions, sir?
Yes, sir.
Then, sir, this is the question, sir, from your aims 2013, 2003, sir. Characteristics are produced due to dung, 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 dung. Yes, sir. Waiting for your answer, sir. Question number 7, sir.
Sir, B, sir.
Right, sir? We all agree on this, sir? Or shall I explain it, sir?
Explain, sir.
Yes, sir. We know this, sir, na?
Yes, sir, but also explain.
Okay. Chalo. Then we move on to the next question. X-rays were discovered by which one?
A, sir.
A, sir. Good, sir. So we understand that the question that come in the examination hall are pretty straightforward. Do we understand this?
Yes, sir.
See the next question, sir. See, we just saw that point. I gave you that point why they are not possible in hydrogen atom, and see, there's a question there. It's all about how much you remember. What is the answer for this one?
C, sir.
B. Hydrogen is very light.
C.
C, sir. Yes, sir. That is what you need to remember, sir. See, the question in X-rays are pretty straightforward. See, this is CPMT. CPMT is your NEET, way back ka NEET. In producing X-rays, a beam of electrons accelerated by potential difference V is made to strike a metal target. For what value of V of the following X-rays have the lowest wavelength? See, simple question, straightforward question. Can you give me the answer? Yes, sir. Jaldi, sir. Which will have minimum wavelength? See, I've told this so many times, 50 times, still you can't answer it. It's a shame on me. It's a shame on me.
Sir, D.
D is the answer. Why D is the answer? More potential difference.
Inversely proportional to
You have to remember all these things. If you don't remember it, you are out. Next one. Straight away, straight answers.
Lead, sir. D.
Good, sir. So we are getting the hang of it, sir. Next, sir. Yes, sir. Again, sir, you don't remember it, sir. You will be in a fix, sir, and you will be sending SOS message in the examination hall, sir. You will watching each other faces. You will not see each other because the centers will be different. Yes.
Sir, D.
Should not take so much of time. You should give the answer in a splash in 5 seconds. D, sir. That's it, sir. You can't take 2 minutes on this question. If you're taking 2 minutes on this question, you are done. Forget NEET right at this point in time. Do you understand this? If you're
Okay,
taking
sir.
more than 5 seconds to solve this question, forget about NEET. You are never ever going to clear NEET at all. If you're taking more than 5 seconds to solve this. How many seconds you took?
30 seconds.
Too much. Just too much. You are 6 times slow. 6 times slow. You have just done the topic now. Just done the topic 5 minutes before. You're taking 30 seconds to solve this question. Now, you're out of NEET. You will not be able to clear NEET beta like this. This is a straightforward question that should be coming in less than 5 seconds. That is how you save time for the questions that are bigger and that require calculation. Does it require any calculation? Tell me, does it require any calculation? Yes or no?
Sir. No.
We have done it so many times. You can't take 30 seconds. You just can't take 30 seconds. The only way you can clear NEET is you can complete the entire your botany and zoology in 30 to 35 minutes. You complete your entire chemistry in 45 minutes. Then you will have somewhere around 1.5 hours to complete physics. In that 1.5 hours to complete physics, there would be at least 20 questions, 20 to 25 questions, which should be done in 5 to 10 seconds. And then you will be saving time for the rest 25, which you might require to calculate. And that is how you will clear NEET. Else, it's a waste of your time. Don't waste it. Do you understand what I'm saying, bacha?
Yes, sir.
If you take 1 hour to solve botany, you are done. You are done. You are done. You're not clearing NEET. If you take 1.5 hours to clear chemistry, you are done. You will not be clearing NEET at all. This is how you should be fast. Getting my point, beta? I want to wish you good, and that is why I'm telling you all this. You
Yes,
have
sir,
to
yes, sir.
increase your speeds. You have to increase your speeds. You have to increase your speeds, and everything is a lost exercise. This one, now this is from IIT, so you may take time. This is from IIT, so you may take time, but not more than a minute. The potential difference
Option
applied.
C.
Okay, good. This is fast. Answer may be wrong. Let me read the question. I have not read the question. The potential difference between applied to an X-ray tube is increased. As a result, in the emitted radiation, intensity increases. Intensity increases. Oh. The minimum wavelength increases. Yes. The intensity remains unchanged. Yes. The minimum wavelength decreases. Yes or no? So options are C and D, and the correct option is B. If you have said B, your answer is correct. Do you understand this?
Okay, sir.
Okay, sir. So, sir, you, sir, lost, sir, 5 marks, sir. But again, you at least gave the answer in the right time. When you change the potential difference, you change the energy of the X-rays. Energy of the X-rays is proportional to its frequency. It is inversely proportional to its wavelength. I have said this at least 100 times in 2 days. You still can't remember it. Well, it's a fault on my part that I could not have much of your attention. I'm sorry that I could not do it good enough. Anyways, time has already gone. I can't change it now. Next question is this one. Again, as you can see, these people, they don't have time to change the question. They will give the same question repeatedly over and over here. The production of characteristic X-rays is due to what?
Option B, sir. B.
Transfer of energy in collision of electrons. Characteristic X-rays, beta. You forgot how characteristic X-rays are produced. Can't help it. Forgotten how characteristic X-rays are produced? How characteristic X-rays are produced, bacha? Anyone? Fast moving electrons strike the target and they knock off electrons from the lower shell. And from higher shell, electrons jump to lower shell. And in this transition, energy is emitted. So what is the correct answer?
C.
And you have said B. Well, may God give you more wisdom. You understand how many times I have said the same thing?
Yes, sir.
Still you can't remember it. I probably have done a very bad job in teaching you. Sorry. Can't change it. Time has already passed. I have to move on. What determines the hardness of X-rays obtained from the Coolidge tube?
D, sir.
B. B for Bombay.
D for Delhi.
D for Delhi is the correct answer. I'll move ahead to question number 48. Banaras Hindu University. Same question can come. they do not have enough time to make good questions.
Option A.
Do we have a filament in X-ray, bacha? How are X-rays produced? You have forgotten the entire thing. Potential difference between cathode and the anode, sir. That is the answer, sir. Let us move on to the next question, bacha. This is 53. So the answer was D there. Do you understand this? Potential difference? There is no filament in, there is no filament. The filament current gives you the number of X-rays. Did we talk about the number of X-rays there, intensity of the X-rays? Or did they talk about the frequency of the X-rays? Tell me. Frequency of the X-rays, no? Frequency depends on energy, no? How do you change the energy? By having more energetic electrons. Okay, 53.
Option A, sir, will deviate maximum.
If X-rays are passed through a strong magnetic field, then X-rays will deviate maximum, deviate minimum, undeviated, none of these. Yes, bacha. What is the answer?
Will deviate maximum, sir.
Will deviate maximum. That is the wrong answer. Undeviated. They do not have any charged particles. I've already given you the characteristics. So the answer is option C. Do we understand this? Do you understand
Yes,
this,
sir.
bacha?
Yes, sir. Yes, sir.
Okay, sir. Chalo, sir. Next one. 65.
Option C, sir.
Option C, sir. Okay, sir. Correct, sir. This one, sir. As you can see, same question is coming in different ways. Yes. Lambda minimum X-ray depends on what?
Option D, sir.
Option B or D? Option B or option D?
D,
B
sir.
for B for Bombay, or you say 1, 2, 3, 4, that is better. One is A.
Option D for Delhi.
D for Delhi. None of these. Lambda minimum X-ray depends on the energy of the electron.
Applied potential.
What does applied potential do? What does applied potential do? Does it give us
Option B, sir.
does it give us poha and jalebi to eat in breakfast? No. Potential difference does not give us breakfast to eat. It gives energy of the electron. More energy. More is the energy of the wavelength of the X-rays. Okay. This one. This question is based on your knowledge. So let us see how much you know. So you must know that it should be around 1000 volt. That is the answer for this one. Do you understand this?
Okay, sir.
So this is based on your knowledge. And that is why I have given you this one. Okay. So I think one more question again based on your knowledge, it might come. So I will just show you this one. Now, most of the question, pressure inside the X-ray tube is of what order? Here the thing is, you must know the order.
Option B, sir. 2.
No, the answer is C, 3. 10 raised to power minus 5, 76 mm wedge is too high. It's a vacuum tube. You must create a vacuum. A vacuum
Okay,
is
sir.
created by having less and less pressure. So these are the questions which are based on your knowledge and your information. So now I think I'm done with X-rays. Whatever I had to do, I have done it. I'll give you 5 minutes now. Go through this entire thing. If you have any doubts, you can ask me now. Else, we are done with this class. Any doubts, you can ask me now. In the next class, we'll be moving on to nuclear physics. Have you got the sheet for nuclear physics as well?
Yes, sir.
Then, sir, in the next class, sir, we'll start with that, sir. So now, the time that you go through your X-rays, if you have any doubts, you can now clear it. You have the booklet with you. If you have not made any notes, which is a wrong practice, but if you have done that unknowingly, go through the entire sheet, 5 minutes of your time. Any doubts, please ask. Else, this class for now is over. I can't do anything new in the 5 minutes that are remaining. So we will do it in the next class. Ask me if there is any doubt.